New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com. New on CuriosityStream.
I'm James Burke. I'm going to take you on a journey through time.
James Burke's visionary series returns, reimagined for our time.
Now, this is all uncharted territory.
The Washington Post hails Burke as one of the most intriguing minds in the Western world. The New York Times raves he careens from one great moment in history to another.
Where do we want to go from here?
Experience all new Connections.
So what's the next connection?
With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
This is SpaceTime, Series 24, Episode 36. Coming up on SpaceTime, is the nearest star cluster to the Sun being destroyed by dark matter? More leaks in the Russian section of the International Space Station. And the Starlink constellation now consists of more than 1,300 satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Data from the European Space Agency's Gaia star mapping satellite has revealed tantalising evidence that the Hyades star cluster, the nearest star cluster to the Earth, is being destroyed by the gravitational influence of a massive but unseen structure within our own Milky Way galaxy. If true, it could provide the first tantalising evidence of a suspected population of so-called dark matter subhalos. These invisible hypothetical clouds of dark matter particles are thought to be relics from the formation of the Milky Way more than 12 billion years ago, and are now spread across the galaxy, making up an invisible substructure that exerts a noticeable gravitational influence on anything that drifts too close. ESA research fellow Teresa Jerebkova, together with colleagues from ESA and the European Southern Observatory, made the discovery while studying the way a nearby star cluster, the Hyades, is merging into the general background stars of our galaxy. The team chose the Hyades simply because it is the nearest star cluster to the Sun. It's located just over 153 light-years away and is easily visible in both the northern and southern hemispheres as a conspicuous V-shape of bright stars that marks the head of the bull in the constellation Taurus. Beyond the easily visible bright stars, telescopes can reveal more than 100 fainter stars, all contained in a spherical region of space roughly 60 light-years across. Star clusters are thought to be made of stars which originally all formed at the same time, but they're only loosely gravitationally bound, so they'll naturally lose stars over time because the stars moving within the cluster gravitationally perturb each other. This constant tugging gradually changes the stars' velocities, moving some towards the edge of the cluster. And from there, the stars are swept out by the gravitational pull of the galaxy, forming two long stellar trails. One of the star trails trails the cluster, while the other pulls out ahead of it. These are known as tidal tails and have been widely studied in colliding galaxies, but no one's ever seen them from a nearby open star cluster until very recently. The key to detecting tidal tails is spotting which stars in the sky are moving in a similar way to the star cluster. And that's where the Gaia Space Telescope comes in. It makes this easy because it precisely measures the distance and movement of more than 1 billion stars in the galaxy. Previous attempts only met with limited success because astronomers could really only look at stars that closely already match the movement of the star cluster. And that would exclude members that left earlier in the Hyades' 600 to 700 million year history and so are now travelling on different orbits. To understand the range of orbits to look for, the authors constructed a computer model that would simulate the various gravitational perturbations escaping stars in the cluster might feel during their hundreds of millions of years in space. It was after running this code and then comparing their simulations with real data that the true extent of the Hyades tidal tails were revealed. In fact, the authors found thousands of former members in the Gaia data. And these stars are stretching out for thousands of light years across the galaxy into enormous tidal tails. But the real surprise was that the trailing tidal tail seemed to be missing stars. And this indicates that something much more brutal is taking place than the star cluster simply gently dissolving. Running the simulations again, the authors found that it showed that the data could be reproduced if that tail had collided with a cloud of matter containing something like 10 million solar masses. And the problem is, there simply are no gas clouds or star clusters that massive nearby. So, if no visible structures can be detected in future targeted searches, the authors are left to speculate that it could mean that the mystery object could be a dark matter subhalo, hypothetical clumps of dark matter that are thought to help shape a galaxy during its formation. It's all just an idea, but it is tantalising nevertheless. This is SpaceTime. Still to come, more air leaks discovered in the Russian section of the International Space Station. And the Starlink constellation now has more than 1,300 satellites. All that and more still to come on SpaceTime.
It's obvious the unthinkable is happening. With all the recent media distractions, most folks never saw it coming. But a few did. Their guts told them something very wrong was going on. And now the headlines are proving them right. The people in charge keep telling you that everything's fine and to stop noticing. But you know better. Folks are investing in emergency food storage, and you should too. My Patriot Supply, the nation's largest emergency preparedness company, are the ones you can trust. Go to mypatriotsupply.com and secure their best-selling 3-month emergency food kits. Each contains tasty breakfasts, lunches, and dinners, averaging over 2,000 calories per day. Get at least one for each family member. My Patriot Supply also sells biomass stoves, off-grid room heaters for when the power goes out, gravity-powered water filters, heirloom seeds, and survival gear that may come in handy soon. Go to mypatriotsupply.com today. It's time to prepare for what's coming. mypatriotsupply.com.
The crew aboard the International Space Station have once again resorted to using tea leaves to try and find more air leaks in the Russian Zvezda module. The Zvezda service module includes the Russian sleeping quarters, galley, and bathroom. It's a key part of the orbiting outpost. Cosmonauts have been searching for this latest leak for several weeks now. They were first told to float thin strips of paper in the module to try and pinpoint exactly where the leak could be. That allowed them to narrow it down to 3 possible locations. But they couldn't get any more precise than that. So mission managers in Moscow then instructed the Russian crew to try the old tea leaves trick again, releasing the tea leaves in the module, which then inevitably slowly floated towards a small crack in the module's hull. Cosmonauts used adhesive tape to provide a temporary seal to the crack until a more durable patch can be applied. But there's still a problem, because there's still a leak in Zvezda, somewhere else. So, needless to say, they'll be relying on tea leaves yet again. These latest dramas follow last year's successful leak hunt, which was also traced to the Zvezda module. That leak began when atmosphere was first detected venting into space from the orbiting outpost back in September 2019. The problem was initially so minor they didn't worry about it too much. But gradually it began to get worse and worse. Mission managers were eventually forced to order a concerted effort in August last year to try and find the source. And by October, with the help of dried tea leaves, the leak was traced to a scratch in the wall of the Zvezda module, and a patch was applied using tape. It's all pointing to a real problem with the Zvezda module, which looks like it may well and truly have passed its use-by date. Of course, leaks in Russian spacecraft are nothing new. Back in August 2018, a 2mm diameter drill hole was discovered in the orbital module of a Russian Soyuz capsule docked to the space station. The Russians are refusing to admit anything, but it seems the hole was accidentally drilled into the side of the spacecraft during its manufacture and was then quickly patched up and painted over. The problem was then either ignored or simply overlooked during so-called quality control checks by Roscosmos, and the patch eventually failed in orbit. Cosmonauts on the orbiting outposts were able to fix that hole using an epoxy sealant. As for the new hole they're looking for on Zvezda, well, I guess it's all in the tea leaves. This is SpaceTime. Still to come, SpaceX launches another 60 Starlink satellites, bringing the constellation to more than 1,300 satellites. And we look at the nearest star system to the Sun, the Lyrids meteor shower and the Southern Cross on April Skywatch. All that and more still to come on SpaceTime.
Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
SpaceX has just launched another 60 Starlink satellites as it continues to build its record-setting broadband constellation. The mission aboard a Falcon 9 rocket blasted off from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. It was the sixth flight for this same Falcon 9 booster, which had last flown just 45 days earlier, setting a new turnaround record. That booster then successfully landed aboard the drone ship Of Course I Still Love You, which had been pre-positioned some 630 kilometers downrange in the North Atlantic Ocean. This latest Starlink mission means SpaceX has now placed some 1,385 Starlink satellites into orbit as part of their initial plans to have 1,440 satellites in their Starlink constellation. The satellites are placed into 72 550-kilometer high orbital planes. But it doesn't end there. SpaceX has already sought approval to launch some 30,000 more Starlink satellites. Astronomers, however, remain concerned about the effect such a massive constellation would have on their ability to undertake vital science. The project's also sparking widespread community debate about the ethics of a single company unilaterally changing the night sky's appearance so drastically. This is SpaceTime. And time now to check out the night skies of April on Skywatch. April is the fourth month of the year in the Gregorian calendar and the fifth in the early Julian calendar. The Romans gave this month the Latin name Aprilis. Although the name's origins aren't certain, traditional entomology suggests it's from the verb aperire, to open, as in it being the season when the trees and flowers begin to open as the northern hemisphere moves into spring. April is also Prevention of Cruelty to Animals Month, and so it's a good time to consider adopting a shelter pet or donating to an animal welfare charity. High in the southern sky during April, you'll find the Southern Cross and its two pointer stars Alpha and Beta Centauri. The more distant of the two pointer stars from the Southern Cross is Alpha Centauri, which also happens to be the nearest star system to our own. Located some 4.3 light-years away, Alpha Centauri actually consists of three stars. There's Alpha Centauri A and B, which orbit each other, and Proxima Centauri, which orbits the pair. And at 4.25 light-years distant, it's currently the nearest star to the Earth other than the Sun. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It's slightly bigger, having about a tenth more mass than the Sun, and has about 50% more luminosity. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, Spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are spectral type M red dwarf stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral to represent luminosity. So, our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars called brown dwarfs. These are sometimes born as spectral type M red dwarf stars, but become brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Orbiting in a binary system with Alpha Centauri A is Alpha Centauri B, a spectral type K orange dwarf star, a little smaller and cooler than the Sun, with about 0.9 times the Sun's mass and about half its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years. The distance between the two stars varies between roughly that of Pluto and the Sun and that of Saturn and the Sun. The third star in the system, Proxima Centauri, sometimes called Alpha Centauri C, is a spectral type M red dwarf star, with roughly a seventh the diameter and about an eighth the mass of the Sun. It takes around 550,000 Earth years to orbit Alpha Centauri A and B. The nearer of the two pointer stars to the Southern Cross is Beta Centauri, also a triple star system, but this one located a far more distant 390 light-years away. All three are massive young blue stars, far larger and more luminous than the Sun. Two of the stars, named Beta Centauri AA and Beta Centauri AB, orbit each other, while the third star, Beta Centauri B, orbits the primary pair every 1500 Earth years. Beta Centauri AA and AB are known as a spectroscopic binary, orbiting each other every 357 Earth days. Spectroscopic binaries are double-star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our point of view here on Earth at least, by their spectroscopic signatures. Both these stars are now reaching the end of their time on the main sequence and will soon run out of the core hydrogen they use for fusion, the process which makes stars like the Sun shine. The two pointer stars, Alpha and Beta Centauri, are named after Chiron, the centaur, a mythological Greek being half man, half horse. Chiron taught many of the Greek gods and heroes, but was placed among the stars after accidentally being shot with a poison arrow by Hercules. Next to the pointer stars is the spectacular Southern Cross, or Crux, the smallest but one of the best known of the 88 constellations in the sky. The Southern Cross is considered an important constellation for navigation and is featured on the flags of several nations, including Australia, Brazil, New Zealand, Papua New Guinea and Samoa. In April, the Southern Cross lies on its side in the early evening, but becomes more and more upright as the night progresses. The bottom and brightest star in the Southern Cross is Alpha Crucis, or A Crux, which is actually a multiple star system located 321 light-years away. It consists of three stars, A1 Crucis, which is a spectroscopic binary, and A2 Crucis. A2 Crucis and the primary star in A1 Crucis are both spectral type B blue stars, with surface temperatures of 26,000 and 28,000 Kelvin respectively. The two components orbit each other every 1,500 Earth years at an average distance of around 430 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres or 8.3 light minutes. The spectroscopic binary A1 Crucis is thought to comprise two stars, with about 10 and 14 times the mass of the Sun respectively. The pair orbit each other every 76 Earth days at a distance of around 150 million kilometres, in other words, one astronomical unit. The masses of A2 Crucis and the larger component of A1 Crucis are expected to eventually explode as core collapse supernovae, ending up as neutron stars, while the smaller component of A1 Crucis could survive as a white dwarf. The left-hand and second brightest star in the Southern Cross is called Beta Crucis, and it's also a spectroscopic binary, consisting of two stars orbiting each other every 5 Earth years, at an average distance which varies between 5.4 and 12 astronomical units. Beta Crucis is located some 280 light-years away. The primary star, Beta Crucis A, is a spectral type B Beta Cephei variable blue star, which changes in brightness over a period of around 4 to 4.5 hours. It has about 16 times the Sun's mass, about 8 times its diameter, and a surface temperature of some 27,000 Kelvin. By comparison, our Sun has a surface temperature of just 6,000. The second star in the system, Beta Crucis B, has about 10 solar masses. A third companion has also been detected in the system. However, it appears to be a low-mass pre-main sequence star which hasn't yet commenced nuclear fusion. Near Beta Crucis is the spectacular young open star cluster known as the Kappa Crucis cluster, or NGC 4755, and more commonly referred to as the Jewel Box, the name given to it by famous 18th century astronomer John Herschel. Open star clusters are groups of stars which were originally all born at the same time out of the same collapsing molecular gas and dust cloud. Although somewhat still gravitationally bound to each other, stars in open clusters eventually separate, moving to other parts of the galaxy. As the name suggests, the Jewel Box is a stunning collection of more than 100 bright, colourful stars, located some 6,440 light-years away, although its exact distance is somewhat difficult to determine because of the nearby Coalsack Nebula, which obscures some of the light. The Coalsack is a dark nebula containing lots of gas and dust blocking out background stars. In Australian Aboriginal Dreamtime legend, the Coalsack forms the head of the Emu constellation, with the dark dust lanes of the Milky Way forming the emu's body and legs. The central parts of the Jewel Box are framed by bright stars making up an A-shaped asterism. These are among the brightest known blue, white and red supergiants in the Milky Way. Gamma Crucis, which is located at the top of the Southern Cross, is the third brightest star in the constellation. It's also one of the nearest red giants to our solar system, located just 88.6 light-years away. Although only 30% more massive than the Sun, its expanded outer envelope is bloated out to some 84 times the Sun's radius, and is radiating some 1,500 times more luminosity than the Sun. As a red giant, no longer on the main sequence, Gamma Crucis is nearing the end of its life. Its surface temperature is some 3,626 Kelvin, and it has a prominent reddish-orange appearance. The star on the right-hand side of the Southern Cross is Delta Crucis, a massive, hot and rapidly rotating star that's in the process of evolving into a red giant and will eventually end up as a white dwarf, the stellar corpse of Sun-like stars. Delta Crucis is located some 345 light-years away and has about 9 times the Sun's mass and 8 times its radius. It's presently radiating at around 10,000 times the luminosity of the Sun at an effective temperature of 22,570 Kelvin, causing it to glow with a blue-white hue. The smallest star in the Southern Cross is Epsilon Crucis, which is located in the space between Delta and Alpha Crucis. It's a red giant, some 228 light-years away. It has about 1.42 times the mass of the Sun and about 32 times its radius. Its surface temperature of 4,148 Kelvin means it's sometimes referred to as an orange giant. The Southern Cross is at its highest point in the southern sky this time of year and is pointing directly at the southern celestial pole. It's within the constellation Centaurus the Centaur, the half-man, half-horse of Greek mythology we mentioned earlier. The creature is holding a bow loaded with an arrow. The Centaur's front leg is marked by the 2 pointer stars Alpha and Beta Centaurus. His back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster visible with the unaided eye from dark locations. Unlike open star clusters, globular clusters are tightly packed spheres containing thousands to millions of stars, which were originally all thought to have been born at the same time from the same molecular gas and dust cloud. Omega Centauri is about 16,000 light-years away. It's one of the largest and brightest of the hundreds of globular clusters known to orbit around the Milky Way galaxy. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. The constellation Orion the Hunter is still clearly visible in the northwestern sky this time of year, with its rectangle of 4 stars surrounded by a central trio of stars which form Orion's belt. To the right or east of Orion is the constellation Gemini and its 2 brighter stars, Pollux and Castor. This time of year, the Gemini twins are almost directly due north for Southern Hemisphere sky watchers. The higher of the 2 stars, Pollux, is a red giant, some 11 times the diameter of the Sun and located just 34 light-years away. The other star, Castor, is much further away, some 51 light-years. Look to the east and you'll see the star Regulus, the brightest star in the constellation of Leo the Lion. Regulus, which means Little King, is located 77 light-years away and is about 3.5 times as massive as the Sun and about 140 times as luminous. Regulus is a binary companion star, which takes 130,000 years to orbit the primary. To the right of Regulus, and virtually due east in the sky right now, is the star Spica. Located directly below the 4 stars in the constellation Corvus the Crow, Spica is the brightest star in the constellation Virgo. Also known as Alpha Virginis, it's the 16th brightest star in the night sky, and is another spectroscopic binary, comprising 2 stars closely orbiting each other every 4 Earth days. In fact, the 2 stars in Spica are orbiting so close together that the gravitational interaction between them has caused them to become rotating ellipsoidal variables, distorting them into the shape of a rugby league or gridiron football. Light from this binary changes in brightness as the 2 stars orbit each other, exposing their elongated hemispheres to us. Spica is located some 260 light-years away. It is some 2,000 times as luminous as the Sun. Spica means ear of wheat, which Virgo is holding in her hand. It's so named because it marks the start of the harvest season in the Northern Hemisphere. The primary is a blue giant variable Beta Cepheid, which undergoes small rapid variations in brightness because of pulsations in the star's surface thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7.5 times its diameter. Once a spectral type B blue-white main sequence star, it's now pulsating rapidly, rotating at more than 199 kilometers per second over a 0.1738 Earth-day period. It's one of the nearest stars to the Earth, which is expected to end its life as a Type II core collapse supernova. The second star in the system is also thought to be a spectral Type B blue-white giant, about 7 solar masses and 3.6 times the Sun's diameter. Okay, going back to the Southern Cross and looking to the right or west, you'll see the star Canopus. It's the second brightest star in the night sky after Sirius. Even though Canopus is 312 light-years away, it looks incredibly bright because it's huge, 100 times the diameter of the Sun and 10,000 times as luminous. This year's second major meteor shower, the Hyades, will peak on April the 22nd and 23rd. The Hyades appear to radiate out from the constellation Lyra, close to the star Vega, one of the brightest stars in the sky this time of year. The source of the meteor shower are particles of dust and debris shed by the long-period comet C1861 G1 Thatcher. Sky watchers in the Northern Hemisphere get the best view of the Hyades. However, listeners at mid-Southern Hemisphere latitudes can also see the shower between midnight and dawn. Patient observers will be rewarded with around 18 meteors per hour before dawn from dark sky locations. And now, with a look at what else is happening in the April night skies, we're joined by Jonathan Nally, editor of Australian Sky and Telescope magazine.
G'day, Stuart. Yeah, well, it's April and we're now past the equinox, of course. So down here in the southern half of the planet, we're heading into autumn, or fall, as they would call it in most places in the northern hemisphere, and up in the northern hemisphere, heading into spring. But for us down here, we're slowly shifting towards our winter constellations. So as the night falls, the Milky Way is up there, and we can see it stretching right across the sky from the southeast to the northeast during the first half of the night. night. By the early morning hours, as the Earth turned a little bit on its axis, the Milky Way will be stretching from the southwest to the northeast. So it seems to change direction. That's because the Earth is changing direction as we rotate. And as the night rolls on, some of the more familiar constellations and the famous constellations of summer are beginning to drop out of view in the west, such as those constellations like Taurus and Orion. Other ones such as Gemini and Leo are still there in the night sky to the northern part of the night sky for us down here in the south, and down to the south is for people in the north. But they're still around just for a little while longer. And what we in the southern hemisphere call the winter constellations are the rising in the east after nightfall. Some of the really good ones, in fact, talking about Sagittarius, Scorpius, and Capricornus, and Aquila. People might not have heard of Aquila, but they've probably heard of Sagittarius and Scorpius. These are particularly amazing, Sagittarius and Scorpius in particular. All you need is a pair of binoculars and somewhere dark, and you can just spend hours and hours just sweeping up and down the length of this part of the Milky Way, admiring all the star fields and the star clusters and the nebulae and things, and particularly if you can get away from light pollution. Don't go outside, out onto your front yard and stand underneath a street light, because you're just not going to see anything. So you've got to get to somewhere dark, even if it's in the backyard, just as long as you're blocking out as much light as you possibly can.
How does that work in the city, Bud? If you're a city slicker like me, that doesn't seem to help at all.
Yeah, look, all you can do is do your best. Just try and, if there's a light that's annoying you, try and just get behind a wall, go around behind a wall or block it out somehow. Look, even if you have to go inside into a room and look out through, open the window and look out through the window, so you're just blocking any direct light. You don't want direct light coming into your eye. You want your eye to be as dark adapted as possible. Most of the light pollution that affects you is within about a radius of about 3 kilometres, or about 1.5 miles, 2 miles of you. So if you can get to a spot, maybe if it's safe, go to a park or a sports field or something. I'm not talking about midnight or whatever, just in the evening. Maybe with a family member or
binoculars,
friend.
middle of the night, dark area, sports field. Yes, I think the local constabulary would be very interested in that.
Make sure you take a copy of Australian Sky and Telescope along with you, with the star chart opened up in the middle, so that you can you can demonstrate what you're doing. But yeah, just try and get away from as much light as you can. It is very hard in the city, but and of course, the later you leave it at night time too, then a lot of lights get turned off, and you're left with just, say, the street lights around you. House lights and things have largely been turned off. All you can do is do your best.
Is the zodiacal light a big problem?
No, in fact, it's not. The zodiacal light is basically light that's reflected from dust in the solar system.
From Mars, actually, we now know.
Yeah, look, it's not. In fact, if you can see that, that means you've got really good dark skies, because it isn't bright, and it is something that astronomers love to go out and see, because it's something you don't see often. You're certainly not going to see it from the city. So no, if you can see the zodiacal light, then really that's an indicator that you have some really seriously dark skies. And it's a great thing to see, because I'm not sure I've ever seen it, to be honest. Just a faint glow in a particular region of the sky through the sort of region of the zodiac, which is just basically the path across the sky where the sun and the moon go. So no, it doesn't drown out other things. Other things drown out the zodiacal light. Yeah. So no, if you get yourself to some outback skies, or out in the desert, or just anywhere rural, away from lots of lights, then you might have a chance of seeing that. And that is a good indication that you've got some dark skies. So if you've got some dark skies, sweep through the Milky Way with your binoculars, or even if you've got a little telescope, you can have a look through as well. In the early evening, we've got the Southern Cross nice and high down in the south at this time of the year. Got the bright star Canopus high in the south-southwest. That's the brightest star in the constellation Carina, and the second brightest star in the sky. And the brightest star in the sky, Sirius, for us here in the southern hemisphere at least, is almost overhead in the early evening from the latitude of around about Sydney. You just can't miss Sirius. It is the brightest star in the night sky. It's really beautiful, in fact. Now, I mentioned Carina, that constellation Carina, that Canopus is the brightest star of. Grab hold of a star map, such as the one you can find in Australian Sky and Telescope, and use it to find Carina. Then grab your binoculars and start sweeping through the star fields in this area of the sky. I mentioned Sagittarius and Scorpius earlier and how you can sweep around with binoculars there. Well, get your binoculars into the area of Carina, because for us who have the joy of living in the southern half of the planet, we think that this area of Carina is just as good, if not better, than the Sagittarius-Scorpius area. It is just glorious. If you've got some nice dark skies and you've got some binoculars, it gives you a wide field of view, and you can take in these sweeping star fields, and it just takes your breath away. Sweep along to the left from Carina, go to the left from Carina and you'll come to the Southern Cross. That looks amazing as well. Here, one of the stars of the Southern Cross, you'll see a little cluster of stars called the Jewel Box, because the stars are multicoloured in there. That's really beautiful. And just beside the Southern Cross, and about the same size as the Southern Cross, is a big dark patch that appears to have no stars in it. Just this big dark patch. And that's called the coal sack, for obvious reasons, the coal sack. And it appears dark simply because it's a big, thick cloud of interstellar dust, and it's blocking the light of all the stars that lie behind it. That's really quite impressive to see too. And you can see that with the naked eye. If you get to some really dark skies, you just see the Southern Cross and next to it this big dark patch. It's really quite impressive. Keep going along from the Southern Cross and you get to what we call the two pointers. These stars called the two pointers, which are Alpha and Beta Centauri, and they're quite close together. And they're a famous pair of stars, and they're called the pointers because if you draw a line through them, it more or less points directly to the Southern Cross. One of those stars, Alpha Centauri, is a double star system, possibly triple star system, with a little tiny star called Proxima Centauri, which you can't see. Let's talk about the planet. And as far as the planets go at the moment for this month, we have some good news and we have some bad news. And the bad news is that Mercury and Venus will be either hard or impossible to see this month, April. Mercury is very low in the eastern sky just before dawn during the first part of the month. So low, in fact, that you probably won't be able to see it because you'll have trees or houses or something in the way. It's going to disappear into the sun's glare as it heads around to the other side of the sun from us and reaches what astronomers call superior conjunction, which just means it's in the same direction as something else, in this case the sun. And superior means it's on the other side. And inferior conjunction would mean that it's on the same side of the sun as we are, and that would mean that it's going in between the sun and us. But at the moment, it's going to be in superior conjunction. Venus is in superior conjunction during April. It's already around the other side of the sun, so we can't see that either because it's lost in the sun's glare. Both of those planets will return to our skies, though, in May, in next month, so they're not going to be gone forever. Good old dependable Mars is visible during April for us here in the southern hemisphere. It's in the northwestern sky after sunset, and there are a couple of things to watch for this month. First of all, on April the 17th, you'll see the Moon and Mars close together in the sky. And this makes for a really easy way to identify Mars if you're having trouble telling it apart from the surrounding stars. All you need to do is go out on the 17th, find the Moon, and then the nearest brightish reddish star-looking thing nearby will actually be the planet Mars, okay? So that makes it really easy. And then once you know where that is, you can go out the next night and you can see where Mars is again. The Moon will have moved. The Moon won't be in the same spot because the Moon moves each night, but Mars won't have moved dramatically from one night to the other. Now, if you've got a pair of binoculars or a small telescope, another thing with Mars is to take a look on the night of the 27th, not the 17th, the 27th, because you'll see Mars right next to a cluster of stars known as Messier 35. And this is a beautiful open cluster of stars. They're sort of a random pattern, and you need a fairly wide field of view optical instrument like binoculars or a small telescope in order to see this, to be able to see Mars and all these little stars in the background with it as well. Messier 35 sounds like a strange sort of name. It's number 35 in the list of objects compiled by a French astronomer called Charles Messier in the late 18th century. He was a fellow who was looking for comets. He loved to look for comets, and some of these what we call deep sky objects, these star clusters and other things, when you look at them through small telescopes of the kind he would have had, and particularly with maybe some optics that weren't the best, not as good as optics he would have now, he would look through these things and initially they would look a bit comet-like, and then he would realise, hey, it's not a comet. So he'd made this list of things that he'd found in the night sky so that he wouldn't forget them. He would know where they are and what they were, so that next time he went out and saw something and thought, oh, is that a comet? He could look it up and he says to think, oh, no, that's not a comet. I saw that thing, last month, and it's just a cluster of stars.
Stuff to avoid.
Yeah, stuff to avoid. And ironically, this list, this catalogue of deep sky objects, as we call them, became the most famous deep sky object list of astronomers everywhere, because while he was interested in comets, other astronomers were interested in things like star clusters and nebulae and all the stuff that he put on his list. So that's why we still remember his name. And the other two bright planets that we can see are in the eastern half of the night sky in the early morning hours. I'm talking about Jupiter and Saturn. You can't miss them, but you have to be up between midnight and dawn. They're the two brightest star-like points of light you'll see in the eastern half of the sky after midnight. Jupiter is the brighter of the pair. It looks sort of big and bright and white, and Saturn is just a little bit dimmer and has a yellowish tinge to it. If you've got a small telescope, or you can borrow one, or a neighbour's got one, or a family member or a friend or whatever, you can have a look at Jupiter and Saturn. And Jupiter, you'll be able to see a bit of detail on it in its atmosphere if you've got a big enough telescope. And you'll certainly see some of the larger moons, the Galilean moons, so-called, because Galileo is the first guy to spot them. They'll be sort of spread out either on one side or the other, or two on one side and two on the other, or three on one side or one on the other, either side of the planet. And with Saturn, you might, depending on the size of the telescope, you should be able to see a bit of, at least, it won't be a point of light in the sky anymore, is what I'm trying to say. You will see a planet, and hopefully you'll see the rings as well. And the rings are tilted pretty nicely towards us at the moment, I think about 17 degrees or so. As the Earth orbits the Sun year after year, and as Saturn orbits the Sun year after year, and we're both at slightly different angle, our orbits to the Sun, eventually it gets to the point where the line of sight effect lines up that Saturn's rings appear to disappear, if that makes any sense. Yep. We actually see them edge on. This happens from time to time. Yeah, we see them edge on. So that's going to happen, I think, I can't remember exactly when, sometime in the next 8 or 9 years or so, but sometime soon. And we will see, Saturn's rings will disappear. We see them edge on really, really thin, which is itself is quite amazing to see, because if you're accustomed to looking at Saturn, and you look at Saturn, you think, well, where are the rings gone? That's quite amazing to see as well.
One ring to rule them all.
Yes.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.